A very good day I bid to our respected lecturer Dr. Fatihah Ramli and all fellow classmates. Group 6 Sarawak Smart Solution members consisting of Shah, Mama Asyraf, Natalie, Stanislawa, and Nicholas Dinningham, are here to present a project on DBKU Intelligent Waste Collection and Monitoring System. A project goal is to improve the waste collection efficiency and environmental quality using IoT and data analytics. First, regarding the measurable organization value, the primary goal is to improve the service, efficiency, and environmental quality. The MOV dimensions include first, operational efficiency, which is to reduce fuel usage by 15% and collection time by 20%. Second, environmental dimension is to reduce overflowing bins by 50%. Third, social dimension, which is to reduce complaints. Fourth, transparency dimension, which is to increase dashboard usage. Time frame 6 months after deployment. Before I proceed any further, I shall give a brief overview of assignment 1. The team formation assigned to roles to team members based on their strength in terms of knowledge and skills. Team leader who will do coordination and oversight, technical analysis in charge of IoT systems and sensors, sustainability analyst who will be in charge of environmental metrics. In terms of human resources, the team, DBKU stakeholders, contractors, technologies, IoT, sensors, dashboard, and mobile app. Facilities, Unimas Labs, DBKU, operations area. The training needed is just sensor usage, dashboard, and maintenance. Regarding the project scope, we have clear boundaries and expected deliverables. The system includes IoT, bin sensing, cloud dashboard, routing, optimization, and reporting module. Exclusions of hardware manufacturing and public education programs. Next, my team shall proceed with the next part of our presentation.
Hello, my name is Mama Asyraf Jeffrey. Starting with slide 6, we established the framework for our project. We mapped the standard project life cycle, which is PLC phase initiation, planning, execution, monitoring, and closing directly against our system development life cycle, which is SDLC. By linking phase like concept and design to the broader project plan, we ensure that every technical step remains aligned with our project's measurable organizational value, which is MOV. Next, on slide 7, we have the deliverable structure chart. This visualizes the major deliverables required for each phase of the PLC and SDLC. Next, moving on to slide 8, this use case diagram defines the system interaction. We identify key actors such as the DBKU admin and drivers. The diagram illustrates how they interact with the system. For example, monitoring bins or optimizing routes, ensuring the system functionality directly supports the business goals we identified earlier. Here on slide 9 is our work breakdown structure. We further decompose the deliverable into specific tasks and subtasks. This WPS provides the necessary foundation for our estimate, allowing us to accurately schedule time and allocate resources effectively across the project phase. The next one is slide 10, provides an overview of the execution phase. Building on our previous assignment, this portion focuses specifically on the execution planning for the DBKU IoT waste monitoring system as listed here. We will now cover the critical implementation details, including the risk assessment, conversion strategy, and our closure checklist. The next one is slide 11. For the scheduling analysis on slide 11, we have produced a clear comparison between our original schedule and the revised schedule. As noted in the slide, we applied a strategic 10% reduction to the original timeline of 120 days. The data present here provides the evidence for how we optimize the schedule without compromising the project scope.
Hello, my name is Shah Fikri. Moving to our financial planning, the original budget for the IWCMS project was set 200,000 ringgit. However, through strategic optimization, we have successfully revised this to 160,000 ringgit, achieving a significant 20% cost reduction. We reached this goal by negotiating better rates for IoT hardware, adopting open source software tools, and implementing lean manpower planning. Essentially, we are delivering the same high-tech solution, being more fiscally responsible. Of course, a project of this scale comes with risk. We identify 5 keys, which is scope creep, potential system function, low user adoption, data errors, and legal compliance. To safeguard the project, our mitigation teams include strict scope control, early prototyping to catch technical bugs, and comprehensive training and communication to ensure that DBKU staff feel confident using the new system. Let's look at how we turn this into reality. Our implementation strategy is designed for stage deployment to ensure smooth transition for DBKU. By aligning every activity with our work breakdown structure, we ensure that no task is overlooked and the system integrates seamlessly into existing municipal operations. We will execute this in 5 clear steps. First, procurement and preparation. We will source and configure the IoT hardware. Second, the physical installation and integration of sensors onto the bins. Third, rigorous testing and quality checks to ensure data reliability. Fourth, using training. So the DBKU staff can master the dashboard and routing tools. Finally, we will move to deployment, starting with the select pilot zones before full-scale rollout. This best approach allows us to minimize risk while maximize the efficiency. Thank you.
Hi, my name is Natalie. I represent the key risks of this project and the strategies we will use to launch the system successfully. To begin, we identified several specific risks that could affect our success. First is scope risk. If we add too many extra features, we might miss our deadline. Next is technology risk. We might face sensor error or internet connection issue. Then people risk. The staff might be slow to use the new mobile apps. We also have the people risk. Buying the equipment or installing it might be delayed. And finally, financial and legal risk. Unexpected costs or breaking city rules. To stop this problem from happening, we develop a strong mitigation strategy. To start, we use clear scope control. This to prevent unnecessary changes to the plan. Second, we do early prototyping. This helps us to find technical bugs quickly. And third, we focus heavily on training and communication. If the staff understand the system, they will be happy to use it. And lastly, we use strict process and compliance check to ensure everything is legal and on time. Now let's look at our conversion strategy. This explains how we turn the system on. We choose a phased strategy. This means we do not launch everything at once, but we do it step by step to catch issue early. Step 1 is turning on the sensor monitoring. Step 2 is turning on the routing system. And step 3 is turning on the reporting tools. There are 4 simple reasons why we choose this step-by-step method. Number 1, it is safer. If one part fails, the rest of the system is still okay. Number 2, it is flexible. It is easier for us to adjust the setting. Number 3, it is cost-effective. We don't need to run a huge operation at the same time. And number 4, it is practical. It matches the manpower available at DBKU perfectly.
Now, we move on to the project closure phase. A solid closure plan is essential to make sure we don't leave any loose ends before handing the system over. Our plan focuses on 5 key things: verifying that the deliverables work, finishing staff training, settling the financial, achieving our documents, and documenting any lessons we learned along the way. In conclusion, this project has established a complete and realistic roadmap for the DBKU IoT waste monitoring system. We have covered everything from implementation and risk management to the final handover strategy. We are confident this plan aligns perfectly with DBKU goals for a more efficient and modern waste management system. Thank you. This table breaks down the specific activities required to close the project. As you can see, we have assigned a responsible party to every task, from verifying the software works to getting the final user acceptances sign off. This checklist ensure accountability and guarantee that DBKU receive a fully functional and documented system. To summarize the value we are delivering, we look at 4 categories. The first one is operational efficiency for saving time and fuel. Second one, environmental impact, catching overflowing bins early. The third one is social value, reducing citizen complaint. Number 4, transparency, using the dashboard analytic to keep everyone improved. Each of these category has a dedicated owner to report progress. Next, how do we measure success? We call this MOV, or measure our organizational value. For the first 6 months, we have set the strict target. We are aiming for a 15% reduction in fuel usage and a 50% drop in overflowing bins and complaints. This table outlines exactly how we will track these numbers and logs and sensor data.